All right, so we're still in section 1.5, still looking at applications. And now what we're going to do is go down and look at example 2. But before we look at example 2, I want to remind you of what the Pythagorean theorem is. Pythagorean theorem is used specifically for when I'm dealing with a right triangle. And we know that a squared plus b squared is equal to c squared. Now, I don't really love that particular formula because if the letters are all changed, then it gets a little bit confusing. So instead of a squared plus b squared equals c squared, I tend to say leg squared plus leg squared equals hypotenuse squared. Just remember that the two legs are always going to be touching the right angle. The two legs touch the right angle, and the hypotenuse is the side that does not touch the right angle. So you just have to remember what the legs and the hypotenuse is. So let's go ahead then and move to example number 2. And it says we have a piece of property that is twice the shape of a right triangle. The longer leg is 10 meters shorter than twice the length of the short leg. And the hypotenuse is 20 meters longer than the length of the long leg. To find the lengths of the sides of the triangular lot. Now, I read through that quite quickly, and so that's a little bit confusing. So what I want to do is I want to pick through this piece by piece. And I know that in your notes you might actually have some values here, but you need to learn how to draw these triangles without any extra helps, just by looking at words. So the first thing that we're going to take a look at is we have a piece of property that's in the shape of a right triangle. I already have a picture drawn there, so that piece is taken care of. The long leg is, now I'm going to stop right there. Notice that this guy here is my long leg, and is an equals. So my long leg is 10 meters shorter than. So 10 meters shorter than says that I'm going to do something minus 10. Let's keep reading to find out it's 10 meters shorter than what? Twice the length of the short leg. Now, let's go and let's call the short leg S. And so if my long leg is twice the length of my short leg minus 10, now I have a full equation there for my long leg. Let's keep on reading. The hypotenuse is, so let's start out with an H equals 20 meters longer than. So just like with the 10 meters shorter than, 20 meters longer than is going to be something plus 20. 20 meters longer than what? The length of the longer leg. So we're going to call that L, the length of the longer leg. Now, what I would like to do when it says to find the lengths of the sides of this triangular lot, the first thing before I go anywhere is I need to make sure that they're all in the same variable. So right now, my short leg, sorry about that, that looks kind of funny. My short leg is called S, so we'll use S's. My long leg can be rewritten in S's with 2S minus 10. Unfortunately, my hypotenuse right now is not written with S's, but it can be pretty easy to do that. Notice that my L is in here, and I can rewrite L with a 2S minus 10. So let's substitute L with 2S minus 10. And then let's go ahead and copy the plus 20 that was already there. And to clean that up, that's going to be equals 2S plus 10. So now my hypotenuse is 2S plus 10. So now that I've got everything that I need for my picture, let's go ahead and use the Pythagorean theorem. So the first thing here is leg squared plus leg squared. So you notice I've got my long leg squared plus my short leg squared is equal to my hypotenuse squared. I'm going to go ahead and FOIL out the first term and the last term. And this is what it's going to look like after it's been FOILed out. And now I'm ready to combine my like terms. And so when I combine all of my like terms, I'll have an S squared minus 80S is equal to 0. GCF is the easiest method to use here. So I'm going to factor out an S. And then I can set up my mini equations so that S equals 0 or S minus 80 equals 0. S equals 0 is already solved. Let's go ahead and solve the other mini equation. And that's going to be S is equal to 80 meters. Now, the first thing that I want to point out to you is that there's no possible way in the world that my lot of land can have a 0-meter side. So I'm going to throw out this solution because of the fact that it's not possible, and I'm just going to stick with the 80-meter solution. But notice I'm not finished. Let's go back to the question, and it said to find the lengths of the sides of the triangular lot. So I'm supposed to find all 3 of the sides. So let's use that S value of 80, and we'll plug that in for the long leg to get 2 times 80 minus 10, which is going to simplify to 150 meters. And then my hypotenuse, remember, it is 2S plus 10, so plug in your S, and you have a hypotenuse of 170 meters. So the 3 sides then, 80 meters, 150 meters, and 170 meters.